This is the 2012 test number 91. So you have a function, and this is the derivative. So I'm going to emphasize that. That is the derivative function. That's what they're saying. And you have selected values, the derivative at 5 particular points. Here's what you have to be careful about, and don't assume things. That's why people are going to miss this question. You're going to assume things about this question that are not true. You're going to look and it's 3 here and it's 1 here. And you're going to say, oh, and it's 4 there, 7 there, 5 there. The derivative is always positive. Look, it's always positive. That is not true. You do not know what's happening between -2 and 0. The derivative could have went from 3 to -10 back up to 1. The derivative could have been negative between those. You don't know. You're just given the derivative at 5 specific points. You don't know what the derivative is between those. You do not know that. Okay? So based on that, let's go ahead and look at question A, or part A. The graph is concave up. In your brain, you better think, oh, that means the second derivative is always positive. That's what you should be thinking. If not, you are in trouble. This is the quiz we had like 50,000 times before break was based on all these. You have to know all those basic justifications. So part A is saying that the second derivative is always positive. Is that true? And you might think, how am I supposed to figure that out? I only have the first derivative. How do I know anything about the second derivative? But check this out. Are you ready? Here, if you were to find the average rate of change there, no, I'm not going to go that route. I'm going to go a different route. Do you agree that f prime at some point must decrease if it goes from 3 to 1? Right? Somewhere between -2 and 0, f prime was decreasing. Well, if f prime is decreasing, you learned if anything's decreasing, its derivative is negative. That's another basic justification. If a function is decreasing, the derivative is negative. So here's the logic. If it went from 3 to 1, f prime has to decrease at some point there. And if f prime's decreasing, its derivative is negative. So therefore, our conclusion is the second derivative has to be negative at some point in this region. Well, that contradicts that the second derivative is always positive. Therefore, this is not always true. That's false. This is an awesome question. And I encourage you, if you're confused, re-watch this video until it makes sense, because this is covering a lot of awesome stuff. And I am going to go backwards. I'm going to start at E now. Let's start at E. F has at least 2 relative extrema. So what is the justification for a relative extrema? In your brain, you should think the derivative changes from positive to negative or negative to positive. That better come to your brain. If that's not immediate, you are not ready for the test and you are in big trouble. The justification for relative max is the point where the derivative changes from positive to negative, and the justification for relative min is when the derivative changes from negative to positive. So looking at this, are we guaranteed that the derivative changes signs twice? We're not. If this were negative, then yes, it went from positive to negative, changed signs. But we can't tell whether it changed signs or not. So we can't say it has 2 relative extrema. So that's definitely not always true. It could be, but it doesn't have to be true. And we're looking for things that have to be true. This is one that might get people. F has no critical points. A critical point in your brain should think when the derivative is 0 or does not exist. And you might say, hey, look, the derivative's never 0. It's always positive. That must be the true one, and you would be wrong. Because remember what I said? You can't assume what happens between these. It could go from 3 to -5 back up to 1. It could be negative in between. It could be 0. It could go from 4 to 0 back up to 7. So to say it has no critical points, you do not know that. It could have a critical point between 4 and 7. The derivative might not exist at 4. Might have a critical point there. So you don't know that it has no critical points. So that doesn't have to be true. So we'll call that false. Here's another tricky one. F is increasing. You say, oh, I know if F is increasing, then the derivative must always be positive, right? Well, and you might look and say, hey, the derivative is always positive. But again, you don't know that. You do not know that because you don't know what's happening between these two. The derivative could be negative between these, causing F to be decreasing and not always increasing. So that is not always true. I'll call that false. Okay, so here is the correct answer is B, obviously, because everything else is false. But here is why. Between 3 and 1, F has to decrease. F prime. F prime, if it goes from 3 to 1, it must be decreasing. If F prime is decreasing, its derivative must be negative. So I conclude at some point here, the second derivative is negative. And then I look from 1 to 4. If F prime goes from 1 to 4, F prime must be increasing at some point. If F prime is increasing, its derivative is positive. Therefore, my conclusion at some point here, the second derivative must be positive. Let's keep going. Look, the derivative goes from 4 to 7 here. Now, I don't know how it could go down and up, but I know at some point, at some point, if it goes from 4 to 7, F prime must be increasing. Well, if F prime is increasing, its derivative must be positive at some point. So my conclusion there is that F double prime must be positive in that region. And then the last region I will do in brown, it goes from 7 to 5. F prime goes from 7 to 5. To do that, at some point, it has to decrease. Well, if F prime is decreasing, then we know that F double prime must be negative. So look, it went from negative to positive, so there must be an inflection point in between there somewhere. At some point between those, there has to be an inflection point. And then it went from positive to negative. Well, if it changed from positive to negative, at some point, there had to be an inflection point. So therefore, there has to be at least 2 inflection points. So this is clearly the correct answer. There must be at least 2. That's a tough question. I care more if you understood my explanation. But that is